Today we're going to talk about the metric system, or the SI units of measurement. In this chapter we will look at the different measurements we will use in chemistry, the units, the prefixes, and how to communicate those measurements. First thing we need to talk about are what are referred to often as the base units. These are the 7 fundamental units that all measurements are based on. And in chemistry, there are a few that we use. The first one we use is mass. We will also often measure time. And the third one we are going to use, which is a new unit for you, is amount of substance. The units for that are moles. Now we can also measure temperature, which we will use. And then there are several others which we just will not use as much in chemistry. A very common one, length, or measuring distance. There's also electric current, luminous intensity, which are often used in physics. So we're going to become very familiar with these. Again, mass, time, amount of substance, and temperature. On page 34, they do also talk about the defined standard. You know, what is a mass? What is a specific amount of substance? What is the specific unit that we measure temperature in for the metric system? The next type of units that we are going to look at are what are referred to as the derived units. And what they are, they're combinations of fundamental units. Two very common ones that you're familiar with, area and volume. You want to take the area of something, you take the length times another length, often length times width. Volume, you measure 3 lengths if we're talking about a cube. If we're talking about a cylinder or some other geometric shape, then obviously we're measuring pi r squared or whatever else is relevant. Another derived unit we will use a lot in chemistry is density. It's not just one measurement, it's actually a combination of measurements. The density takes into account a mass measurement and a volume measurement. Well, a volume measurement is actually a derived measurement of length. So as you can see there, it's several measurements put together. Another common one that people know about, just the speed of an object. Miles per hour, meters per second. How far an object travels in a certain amount of time. There will be quite a few derived units that we will learn in chemistry. We will begin to learn those in this chapter. Now as we move forward, the next thing we need to talk about are the metric prefixes. And these are displayed a lot of different ways depending upon what book you're looking at or what resource you're looking at. On this page here, I've displayed them left to right. And the reason I've done that is so that we're looking at our decimal places. You'll see these reported tera all the way down to atto. Now in chemistry, what are we probably going to be most familiar with or using the most would be in the range from kilo to milli. Just in everyday usage, we are becoming more familiar with tera and giga in terms of computers. Terabytes, gigabytes. 10 years ago it was megabytes. Also, we're becoming, with talking about electronics and circuitry, more familiar with micro and nano. You've often heard of nanoparticles. So we would start to see us working more and more to the left and to the right from this middle section. Now, what we have here is in the middle is what we call the base unit. This is where we have our standard measurement without a prefix. And then every prefix that occurs to the left or to the right moves by a power of 10 or several powers of 10. In the example here in the middle from kilo to milli, each prefix is a power of 10, which relates to 1 decimal place. Other thing that you will see in most charts, and you see that in the chart also in our book, each one of these has talk about a power of 10. Deca is also often referred to as 10 to the first power. Hecto, 10 to the second. Kilo, 10 to the third. Deci, 10 to the minus 1. Centi, 10 to the minus 2. Milli, 10 to the minus 3. So as you're converting from one to the other, we're multiplying or dividing by powers of 10. Outside of that range of kilo to milli, they no longer do just a power of 10. They do the power of 10 3 times. So from milli to micro, it's now 10 to the minus 6 is the value for micro. So we have gone from 10 to the minus 3 at milli to 10 to the minus 6 at micro. Nano, 10 to the minus 9. Pico, 10 to the minus 12, and so on. We come outside of mega, it's 10 to the 6th power. So kilo is 10 to the 3rd, mega is 10 to the 6th, giga 10 to the 9th, and tera is all the way up to 10 to the 12th power. So we need to become very familiar with these as we make measurements and as we convert measurements. Just very simple calculation here that we can look at. At the top here, 197.352 kilometers, and we want to convert it to meters. Or we could say 197.352 grams, and we want to convert to kilograms. Well, if we again imagine where we're at in our base units, we have our base unit where we would have meters. Kilo is the third decimal, or is the third prefix to the left. So we are at kilometers and we are going to meters. So we are moving 3 places to the right. Therefore, the decimal moves 3 places to the right. We are multiplying by a factor of 1,000. So 197.352 becomes 197,352 meters. If we are working the other way, we're at grams here. And we need to go to kilograms. We are moving 1, 2, 3 places to the left. Well, as we move 3 places to the left in terms of prefixes, the decimal point moves 3 places to the left. So we have 0.197352. That is the easiest way to do it, is to just visualize where you're at on the prefix scale and appropriately move the correct number of decimal points. And there are plenty of examples in the book that you can look at to start with. The last thing I'm going to show here is just briefly how you can use the exponential factors to do this. 132.4 terameters down to nanometers. Using exponential factors, the value for terameters is 10 to the 12th. The value for nanometers is 10 to the minus 9th. So if we're going to go from a very large unit tera to a very small unit nano, what we do is we divide the numbers with their exponent. And then we subtract what those exponents are from the original number. So, tera, We're going from tera to nano. 10 to the 12th divided by 10 to the 9th ends up being 10 to the 21st power. So what do we end up doing? We actually move the decimal point 21 places to the right is our correct location now. So we have 132.4 terameters, and we're moving to the right. We're going to move 21 decimal points to the right. So 1.324 times 10 to the second power, 132.4, add 21 decimal points to it, it becomes 1.324 times 10 to the 23rd. Or, if we want to think about moving 21 decimal points, what we're literally saying is 1.324 times 10 to the second times 10 to the 21st. That gets us the same answer. Again, you do not have to show using the exponential factors doing this, but it can be very useful if we want kind of a quick comparison. Just one more I'll do here. Let's say we go from teragrams to micrograms. Tera, again, exponential factor 10 to the 12th power. Micro, 10 to the minus 6th power. Divide the numbers with exponents, and then subtract the exponents from that. So 10 to the 12th divided by 10 to the 6th is 10 to the 18th. So we need to move the decimal point 18 places to the right. So 197.35 teragrams plus 18 decimal points. 1.9735 times 10 to the second plus 18 decimal points becomes 1.9735 times 10 to the 20th power. Or take that original number and multiply it by that exponential factor of 10 to the 18th. All right, so just a couple short things here about the metric system, how to learn the prefixes, and how to convert from one prefix unit to another. Hopefully this helps kind of get you started in the right direction, and that will be it.